Hello, everybody, and welcome to our first Clock Talk with Dr. Brannon. Dr. Brannon is a well-known BHRT, bioidentical hormone replacement provider, owner of Optimal Bio, located in Cary, North Carolina, with 5 other locations, soon to be more, throughout the Southeast. Doctor, welcome.
Thank you very much, Jim. I can't wait to do this and hope we stimulate people to go search more science.
Yeah, so everybody can see the clock, and we're going to spend 15 minutes talking about testosterone today. So let's get started. What is testosterone, and what does it do, and why is it so important for us?
Wow, it's so important because without it, we're not here in the sense of it's the fuel for our body. But what is testosterone? It's in a class of a molecule called a hormone. Hormone means messenger. So what it does is it controls, it tells one part of the body to do something at another at a distance, at a different spot. But a hormone works this way in the sense that it goes into the bloodstream. So it goes everywhere and the cells that need it grab it. Different than a nerve that goes, say, from the brain to the muscle. It actually has to go out the system and then get grabbed. So there's 2 types of hormones. There's a protein hormone, i.e. insulin, and there's a fat hormone, the sex hormones. In fact, our Optimal Bio brand that's called a gonane. That's a steroid that actually, there's 4 rings there. That is the backbone of estrogen, testosterone, progesterone, cortisol, cholesterol. That's the backbone. So what testosterone does is very, very important. It actually, to get a little nerdy, it actually does what the DNA is a picture like a ladder twisted. So there's this alphabet of A, T, C, and G. C always meets with G, T always meets with A. And every 3 of those will equal what's called an amino acid. But how does it get from the DNA to the protein? It has to unzip. Messenger RNA comes in and reads it. The messenger RNA goes to what's called a ribosome and it's transcribed. That process is initiated and controlled by testosterone. Other sex hormones, estrogen, progesterone as well. So that's what it does. It works 2 ways. The classical way is called the genomic. It diffuses through the cell membrane, through the nuclear membrane to the DNA and reads the DNA like we talked about. A newer way, which is very interesting, is because that takes days to weeks to work. There's now what's called the non-genomic state, which is it works within seconds on the cell membrane. Very important for nerve, neuroplasticity and nerve communication. So that's the other process it works. It's crucially important for men. No, for humans. Women and men both have estrogen, both have testosterone. Different amounts, but we have them both. The estrogen in women comes from testosterone. In fact, the way it's set up, the way the body works, the ovary makes testosterone first, which converts to estrogen. In the testicle, it's the same thing. We make testosterone first, becomes estrogen. That's important with the feedback in a moment. But how that works is when it's formed, the testosterone forms to the estrogen, and it goes into the structures and works at each cell. So a couple types. In the bone, it actually makes bone. Why is that important? Think about this. 50,000 women a year die of osteoporosis, more than breast cancer. The number 4 cause of death over the age of 70 is falling down. Not because you fall and trip, your hip snaps, you fall down and then die of pneumonia. So we tell women to do things early on when they're having the hormones. Exercise, weight resistance, that kind of exercise stresses the bone. So why? So the bone's made. So you have more bone in the bank. So when you get menopause, you withdraw every day, but you don't lose it all. Great. Good. I agree with all of that. But why are they making bone? They're making bone because they have a hormone called estrogen and testosterone. That's why they're making bone. So why do we have to, because their fertility range is done, we have to say they're not valuable anymore? Why not keep that young biochemistry working? The bone's the example because the chemicals, the biphosphates that make bone for osteoporosis, they make it differently. They make a hard bone that's brittle. It still snaps. In fact, it breaks the jaw and can break the hip as it's supposed to work. Natural bone is strong but pliable. We should have that as we age. That makes it, in fact, 25% of men have osteoporosis as they get older. So that's not just a woman disease. The other thing it does, metabolically, it makes the insulin receptor more sensitive, which then allows insulin to do its function better to lower glucose. We'll spend time over the series, hopefully next year or so, talking about the evils of glucose. The glucose is, when it's high, it increases dementia, obesity, diabetes, all these things occur. So When you ask the functions, every cell needs it. Every cell needs it. But what's an optimal number is what's very interesting. And it changes with age, or does it change with age? Traviston, in our book, The Hormone Handbook, it's the 7th reference. He looks at the last 5 decades. Every 10 years, the starting point is lower. Why? Also, Harvard came out with a paper about 3 years ago showing men, when they lose with age, age is not the variable. Why? Here's why, Jim. Testosterone converts to estrogen. Estrogen goes back to the brain and says, we have plenty of testosterone, we're done. What if we ingested estrogen? It would trick our body that we make enough estrogen, therefore we make less testosterone. That's the problem the last 50 years. We're ingesting this thing called neuroendocrine disruptors. The biggest subgroup there is called xeno, or foreign estrogens. What are they? Roundup, atrazine, a pesticide, BPA plastic, phthalates, PVC piping. All these things look like or act like estrogen. In fact, they're bombarding babies in the womb, where the generation under us, 35 years older, their sperm count's 50% of ours. In fact, Hebrew University says by 2050, men in Western Europe and North America will be infertile. So what does it do, Jim? It's life, man. That's what this is all about. That's why it's important to find what these numbers are and what they mean. So that's why it's important to understand what a range is.
So let's talk about that. I mean, you mentioned ranges a few times now, and let's just look back in time. 40 years ago, what was the average, 55-year-old male and 30-year-old or 40-year-old female? What were their ranges then? What have they done to the ranges these days? And why aren't there, lots of treatments for testosterone through the mainstream medical community?
Okay, that's fantastic, Jim. If we were having the same talk, what was the range? What was the value we considered diabetes 60 years ago? It was the same, a fasting blood sugar on 105. Period. It's never changed. So we did not commonalize disease. We did not call it something normal and normalize disease. But in hormones we have. That's what's very important to me when I look back at the data. So when I was in school, a male was roughly 800 to 1,1300. Today, depends what lab you use. Duke uses a lab that's 170 to 700. LabCorp uses that value of 264 to 916. But literally, that was to June 30th of 2017. The range was 348 to 1197. Why is the range changing? There is not one single paper in scientific literature for a man or a woman. What is a optimal testosterone level? There's not one. It's always a range of a population base. That's why the population base you're getting your numbers from are crucially important, right? Bad numbers in, bad numbers out. Where is a healthy population? We're not seeing it now, Jim, because we're bombarded, like I said, in the womb. So what I'm trying to do is go back to farther as I can go back. What were they then? Because they're not lower now because we're healthier now. They're lower now because the environment has lower than optimal number. That's what's important to understand. And so they get these population bases. If you have an unhealthy population, that could skew your data. UNC Chapel did a study about 3-4 years ago. It said 12% of Americans are metabolically healthy. Well, if that's your population base, you're saying this range, again, understand what a range is. You get all this numbers, all these data. Usually this says about 10,000 people. You find a median, which is in the middle. Then you take a standard deviation each side. That's the bell curve of 80%. That's what it is. So why is it shifted from the right to the left over the years? I believe, my content, it's the environment. It's not, we're normalizing disease. So your question is why are not mainstream medicine using this? I believe we don't let age, we should look at age as a disease. I'm not talking about immortality. I'm not talking about that. I'm talking, we're living longer now with a chronic disease. How can we push out the 4 top causes of death? Cardiovascular disease, cancer, neurodegenerative disease, and falling down. Just push them as far as you can. Well, if you keep the chemistry, the biochemistry younger, the cell does not know its age. It doesn't. So if you have a healthy chemistry, you'll get those benefits. So I think they don't equate osteoporosis with low testosterone. They just call it another disease. They don't call diabetes a disease because of low testosterone. They call it a disease of sugar. They don't cause dementia a cause of low hormones, like hot flashes. I'll give you an example. Hot flashes are the thermoregulatory bar of the brain where women are controlled by estrogen and testosterone. The sudden drop of hormones appears to be the reason why women are 2 to 3 times higher for dementia because they're losing hormones quickly. So what if you keep the level up there higher? You could actually show, and there's been papers to show replacement bioidentical hormones has actually decreased dementia. But the big fear, though, is these ideas of what an optimal number is as you age. As part of age, you're trying to fight aging. No, I'm not. I just want the chemistry to be healthy. So that's what I'm trying to do. So, Jim, I don't have an answer why they're thinking that way, but if I do believe they think of age as a disease, then you look at the root cause. So our cells are stronger the higher our levels are for a longer period of time.
So let's walk through, there's, I think, 3 traditional testosterone treatments that are, some are synthetic, some are bioidentical, which is what we do at Optimal Bio. Kind of walk through the 3 different applications and or the synthetic versus the bioidentical.
So 1931 was the first time scientists isolated an androgen, androgen. 1935 was the first time they isolated in humans testosterone. And they saw that it was actually stronger and increased protein synthesis, just like we talked about. In fact, in World War I, a German surgeon would take the testicles of a dead soldier and place it in the abdomen area to help fight gangrene. So they know this stuff worked. So in 1935, they have what's called it's endogenous, the structure your body makes. Pharmacy companies cannot own an organic molecule. So they want to make it stronger for certain reasons to manipulate how long the half-life is. So there's 3 classes. One's called an ester, one's called 19-nortestosterone, and one's called 17-alkylation, which can be taken orally. So all 3 of those have a route, shot, oral, or cream. But the problem is not just the route, it's the structure of the molecule. When you hear about testosterone therapy causing high blood pressure and blood clots, it's true. It's not the endogenous one. It's not the bioidentical structure. It's those. They're rare, but they're there. So you want to get, for me, I think you want to get the best chemical, atom for atom, molecule for molecule, 3-dimensional rotation as possible. That's bioidentical. Mayo Clinic defines that as body recognizes as same. Then you want the best way to mimic how the body does it, the testicular ovary. It squirts it into the bloodstream and the cells grab it. Well, if you take a pellet, which is completely 99.5% pure testosterone, it's not a capsule, it's compressed hormone. The other 0.5% is stearic acid or cholesterol, a fat that it's like a glue that's only in the mold. Now it sits in the fat. As the blood or the fluid of the fat, 1 molecule at a time, it's actually 1.7 milligrams per day per pellet, is secreted just like it was into the bloodstream, and the cells grab it. Again, the shots will do this every 3.5 days. The creams will do this. In fact, 40% of creams are not absorbing the skin properly. The one that's oral is fantastic, and it bypasses the liver, so it's not degraded by the liver, which because they knew 17-methyl testosterone as early as 1947 increased blood clots by going to the liver. The new one called testosterone echinocandinate does go orally, half-life's 21 days, but it's absorbed by the lymphatic system. But the problem is only 3% absorbed. And it sells the risk of blood pressure and blood clots. So what I want to do is just use what the body makes at the pre-plastic, pre-xenoestrogen generations. So we want to mimic the testicle, mimic the ovary, eliminate the pharmacokinetics and the structure. And that's what we do at Optimal Bio.
A little bit over a minute left. What are some of the symptoms people are experiencing with low testosterone right now that they should be looking for? And then if they need to go to the provider to get this tested, what do they want to ask for?
Beautiful. I don't care if you're a man or woman, I don't care if you're 20 years of age or 90 years of age. The same thing's the same. Tired of being tired and brain fog. Tired and being brain fog. 3, anxiety, depression, motivation, libido. Remember, since there is no optimal number, there's a range. Treat symptoms. So the doctor asks for a testosterone and a free testosterone and an estrogen and a PSA if you're a man, and FSH and LH. Optimal Bio, we have all the labs on our website we look for. The key thing, Jim, is this. Signs and symptoms are not in your head, or they're not just a nuisance. They literally are a sign of our body degrading. That's what they are. So what we're going to do is make the cell at the molecular level as strong as possible so that organ, the brain, the heart, the bone, the muscle is as healthy as can be. So that us, the human, can have the best longevity, health span, and longevity go concurrent. That's what's key.
Fantastic. Thank you, doctor. A wealth of information in 15 minutes.
Thank you very much.